students, in previous lecture we have seen a Newton-Rapson method to find an approximate root of a given equation f of x. Okay, so these are the total methods, that is bisection methods, false position method, iteration method, Atkin delta square process, and Newton-Rapson methods. These are 5 methods to determine an approximate root of a given equation f of x is equal to 0. Now today we are going to see more examples on Newton-Rapson method. So right now, solve find square root of 10 by using Newton-Rapson method. Okay, so to solve such a type of an example, first we assume here, suppose the value of the square root 10 is equal to x. Value of the square root 10 is equal to x. If you square on both sides, you will get x square is equal to 10. So next, if you take this 10 on left hand side, you will get x square minus 10 is equal to 0. So to solve, to determine the value of square root 10 means what we want to solve the equation x square minus 10 is equal to 0. That is, we want to determine a value of x where this equation must is equal to 0. So here we can say f of x is equal to x square minus 10. Then what is f dash x? F dash x is equal to twice x. And step first, we want to determine an interval containing root. We want to determine an interval containing root. For that, start from 0. If you find f of 0, you will get f of 0 is minus 10, f of 1 is minus 9, f of 2 is 6, minus 6, f of 3 is again minus 1, and f of 4 is what? 6. So if you observe the two successive values 3 and 4, at this point your f of a and f of b have an opposite sign, that is f of 3 is less than 0 and f of 4 is greater than 0. So what this implies, since f of 4 into f of 3 is less than 0, this implies our root lie inside the interval 3 to 4. Okay, so this is our step number first. Now in step number 2, we want to select any approximate root which lie in this interval 3 to 4. You can select any approximate root. You can select 3.1, 3.2, 3.3, any approximate root. So we are going to select here x0 is equal to 3.5, and next successive terms, that is x1, x2, x3, we are going to find by using a Newton-Rapson method formula. So the Newton-Rapson formula, x1 is equal to x0 minus f of x0 divided by f dash of x0. Okay, so x1 is equal to x0. x0 is what? 3.5 minus f of 3.5 divided by f dash of 3.5. So x1 is equal to 3.5. What is f of x? We know that this is the f of x square minus 10. So it is what? 3.5 bracket square minus 10 divided by f dash x is twice x. So 2 times 3.5. So if you solve this, you will get x1 is equal to 3.5 minus 3.5. You can see your calci. So 3.5 bracket square minus 10 is equal to 2.25. Divided by 2 into 3.5 is what? 7. So to simplify this, x1 is equal to 3.5 minus 2.25 divided by 7, you will get 0.3214. So if you subtract this, 3.5 minus 0.3214, you you will get this 3.1786. 3.1786. So this is your second approximate root. Now next we want to determine x2. What is x2? x2 is equal to x1 minus f of x1 divided by f dash of x1. So x2 is equal to 3.1786 minus f of x1. f of 3.1786 divided by f dash of 3.1786. So if you solve this, you will get x2 is equal to 3.1786 minus f of 3.1. What is f of x? 3.1786 bracket square minus 10 divided by 2 times 3.1786. So x2 is equal to 3.1786 minus 3.1786 bracket square minus 10 is 0.1035. This whole divided by 2 into 3.1786 is equal to 6.3572. So if you divide 0.1786, if you divide 0.1035 by 6.3572, it is equal to 0.0163. And if you take the difference of these two terms, you will get 3.1786 minus 0.0163 is equal to 3.1623. So now if you observe the previous two successive roots, that is x1 and x2, they are correct up to 1 decimal places. But we want to determine root must be correct up to 3 or 4 decimal places. So next again we want to determine the value of x3. So x3 is equal to, by using Newton-Rapson formula, x2 minus f of x2 divided by f dash of x2. So x3 is equal to, what is x2? 3.1623 minus f of 3.1623 divided by f dash of 3.1623. So again 3.1623 minus, what is f of x? X square minus 10. So 3.1623 square minus 10 divided by 2 times twice x. F dash x is what? Twice x. 3.1623. So x3 is equal to 3.1623 minus 3.1623 bracket square minus 10 is equal to 0.0001. This whole divided by 2 into 3.1623 is what? 6.3246. So if you divide 3.1623, that is, if you divide this point not 1 by 6.3242, you will get, it is what? 0.0000. Okay, so x3 is equal to what? 3.1623. So now if you observe the previous two roots, that is, if you observe x2 and x3, they are correct up to 4 decimal places. They are correct up to 4 decimal places. So we want to stop here our process. You can say that here, you can say that x2 and x3 are correct up to 3 decimal places, and therefore what is answer here? Answer is what? X is equal to 3.1623. But what is our x? X is what? in step first we have assumed that our x is what, under root 10 is equal to x. So what is the value of under root 10? It is 3.1623, and if you use your calci you will get, it is also correct up to 4 decimal places. It is 3.1622. If you use your calci, it is equal to 3.1623. Okay, so you can compare here that if you apply the Newton-Rapson method and you are calculated in both the method, you will get root correct up to 3 or 4 decimal places. Okay, so